Welcome to the EarthWorks podcast, where our team will share the jargon of carbon with many of the turf friends we've met over the past 35 years.
Hi, everybody. This is Joel Simmons for another EarthWorks podcast. And we have back to the podcast our old friend Kevin Hauschel. Did I say that right?
Yeah.
I was closer anyway. I've not been very good. Kevin was on, I looked this up, Kevin. I think you were on a couple of years ago when you were still at GreenSight and we talked about all the good stuff you guys were doing there. And I only just found out from your dear friend Joe Budnick the other day. I went fishing with him over the weekend. That you had changed jobs and you're doing something very cool. So I got very excited. Joe and I had a chance to spend some time together, and he got to tell me a lot about what you guys are doing. And needless to say, it got me all excited. So I couldn't wait to call you and say, let's get on the podcast and let's talk about this thing. So you are at Rainmaker.Earth, which is the company. And I don't know how to do this better than say, what the hell are you doing? What is this thing?
Yeah. So we're a water treatment system that mimics the effects of rainwater. So basically what we do is we take a 10% offshoot of your main flow of water on any existing irrigation system. We build custom systems and we run it through a booster pump, which then boosts it through a venturi, and we impregnate it with ozone and UV basically oxygen that basically gets pulled down into the water through the venturi. And then what we're able to do is once we boost it through the venturi, we basically are infusing it with nanobubbles or increasing the dissolved oxygen. And at that moment, we inject right before we put it back into the irrigation system, we inject it with 2 parts per million of hydrogen peroxide. And so what that allows us to do is we create a bunch of hydroxyl radicals, which are short-lived, really, really powerful oxidizers that are very beneficial for soil health and that also allow the water to change structure. So we're actually able to change the viscosity of water sources.
So you're making it wetter.
Exactly. So the idea of wetting agents, we're actually restructuring the water to do the same exact principle without needing to introduce a polymer.
And the residues, which is interesting. How long has and you told me that you've been doing this mostly in ag until they brought you on, and I assume you were brought on to kind of get into the turf and ornamental side of things, but how long has Rainmaker been around?
Yeah, so Rainmaker, the technology's been around for 16 years.
Really?
So quite a long time.
Yeah,
it was originally designed to clean irrigation systems, as you could imagine, hydrogen peroxide, UV light with ozone, atmospheric ozone. You're able to not kill things, but you're able to kind of remove biofilms, break down salts, those kind of things, and allows drip emitters.
In the piping, in the irrigation system.
Yeah. So drip emitters, vineyards, orchards, things like that. That's what it was utilized for, was kind of like instead of using acids or shock treatments to keep these, which they have problems with. I've seen too many melted systems around the eggs side of things when acid injection pumps go wild. So so they use this as a simple, gentler treatment. What they ended up finding out was a couple farmers came to him after a couple of years and said, "What are you doing? Because since we put this in, we've had our best yields yet too."
Wow.
And their water use is going down. They're decompacting the soil, et cetera. And so that's what kind of spearheaded this. So then the guy that designed it originally was kind of, or engineered it, was kind of like, I don't know. I just was trying to clean the lines. We designed it for one purpose.
What's happening? Yeah, we designed that for that. Yeah, sure. Wow, show me that again.
So then we went down the rabbit hole of let's get some chemical engineers involved, figure out. And so the company went down, our CEO, Chris Hunt, went down the rabbit hole of figuring out everything. And Bob Knight, our CTO, they went down the rabbit hole of figuring out exactly. And they both had friends in the oil industry. And so the oil industry does a lot of different testing that we don't necessarily do in terms of testing in terms of water quality. And it's because fracking is actually your water quality directly affects how these acrylics and other things they're going to use to frack to push the
Yeah.
oil out. And so he went to, Bob, who had a background in that kind of field, and Bob, he kind of said, hey, let's look at this. And so they went and kind of went and did some testing with some labs that did viscosity testing and wanted to see what was actually happening to the structure of the water. Why were we getting this result? We know we're releasing hydroxyl radicals. We know that we're doing, which are beneficial, but why is the water getting able to penetrate deeper? Even with really high salt levels,
Yeah.
high minerality.
And they had no idea
And
this was a byproduct of what they were trying to do.
correct. And they didn't understand. So then it went, and then they figured out, oh, well, actually, this is what we're doing. It's by breaking the water down and fusing it with the UV and the ozone,
Right.
atmospheric ozone. Then infusing it with hydrogen peroxide, we create these free radicals, right? So the OH radicals. Well, that allows us to oxidize the salts and break the salts down. We don't remove them. It's
Yeah.
not, which
It's a
actually
chemical reaction.
which I would actually argue is we don't want to remove them necessarily. What we want to be able to do is open up the profile so that we can actually move them through, right? And they're
Exactly.
small enough so they're not going to bind. So that's what so once we figured out what we were kind of going, then the next steps were, okay, Chris came to me randomly. We were just down at the show last year, and he came down. We met at a bar randomly, and I've worked with the San Francisco Giants for quite a while. Greg Elliott's uses drones, soil sensors. He has a Rainmaker himself, and so Greg's always, hey, Kevin, every single year he comes to me and goes, hey, what do you got?
What's new?
What's the new?
Yeah.
What are you doing that's new now? I already got robots, I got drones, I got everything else. And so I said, well, I'm really interested. Like, you have the challenge of some compaction because he has years of
Big trucks
monster
on that. Yeah,
trucks.
monster trucks. Yeah,
I mean,
exactly.
you just flooring, things like that. And so,
concerts and all that crap.
yeah, so he was like, well, we're going to have to redo the field at some point. And I'm going to have to redo the subsurface because it's like concrete underneath there. And I was like, okay, well, let's see if we can actually start opening up these layers. And so he'd been doing he brews live biology on site. He's all organic. He's ahead of the game in that regard. Doesn't use pesticides, doesn't use herbicides, doesn't use fungicides anymore, and still holds concerts with fluorine and everything else. Well, what we found is we put the system in, and we were able to, the goal was to decompact. Well, instantly, we're 2 months in, and when I've been out there testing for years, and I could barely get a soil probe into the ground or a profiler.
Yeah.
And so the first month I went out, I could get another 2 inches down. And I went, okay, this is good.
After a month?
Yeah. And so we were sitting there, and I was like, okay, this is good. He has really bad sod layer that came in and a bunch of other things. And so
every sports team does.
And so I was like, well, we're going to help be able to do that, because if we can keep the biology stirred up a little bit more with the oxygen and everything that we're doing on our front, we're going to just like speed up your process basically. And so we went in, and so we started, and we didn't know it was going to go this fast, but that's why we started monitoring it. Next thing you know, he's getting an extra inch of rooting too, because as we decompact the profile and we get, now it's going. Yep. So next thing you know, I get there at 2 months. Now we could only get 3 inches, 4 inches down across the field. Now we're able to get 8 inches down. Beautiful. In certain places to his gravel layer, right? We're able to withstand concerts. He can have the flooring down for a week and pulls it off, and the grass is fine. He doesn't resaw it.
Really?
And in fact, and it's these kind of, we tested, and like I tell people all the time, people go, well, why are sports fields good testing facilities? I said, because they're probably the most controlled environment you're going to get
Right. And there's a lot
with
of
all
compaction.
these challenges. Yeah, with all these challenges that you're going to see on a golf course, on a farm, whatever it may be, you can go in there and I can recreate it. You just go around there's a sports field that's got the problem. I guarantee it around the country.
Yeah.
So, so that's been the fun part is Greg's always been willing to put stuff in and then let's test it and let's prove it out. And so we put that in, and same thing with Joe. And that's why I've chosen to work with them, not only because I knew Joe and we've went to school together and we've kind of come from the same belief system, but it was more because of the fact that we needed to have people that were going to pay attention, if that
Right.
makes sense.
Yeah. You needed somebody to
And
do the research.
yeah, and they have the technology there. So what we've done is we have daily drone flights at both these facilities. We have soil sensors in ground at both facilities,
So you
right?
really you're gathering a lot of data.
We're collecting all the information, and that's always been my thing, Joel, is I'm one of those people. I used to do my own research even when I was up at Meadow Club. I was one
I
of the first.
remember that.
Totally, and I were one of the first people to put Bermuda grass in up in Northern California, and so for us, we were always trying. For me, I've always trying to like learn and continue to advance and figure out new things that are going to help speed up programs that are
Right.
beneficial to the industry,
Right.
right? And the same effect fits into regenerative agriculture. I grew up farming, okay, and
Yeah.
so for me, I've watched family members, I've watched friends make these switches, get no benefits, and then they go right back to their old systems after they wasted all this money. And how do we have to see the same thing in golf? It's like, oh,
Yeah.
they go this way, and then they don't see the answers they want to see, and then they just don't wait, or they're not patient enough,
Yeah.
right? And that's where I think this technology is going to allow guys to start realizing that we can solve a lot of our problems. It might be water quality, it might be whatever, but if we don't talk about water quality from a soil health perspective, it's really
I
not.
do. I talk about
You
it all the
you
time.
do.
Nobody
I
listens,
well
but I
no,
talk
but
about it a lot of time.
yeah, and
No,
how it
no, you're right. I
affects.
mean, water, I mean, water is the single biggest input on a golf course or on any agricultural operation. It's the biggest single input. So if it's crappy water, I mean, you got a problem, right? So let me go
Yeah,
through the mechanism. Talk to
yeah,
me about what's involved in setting up. What's the equipment look like? Go down that road so that I
yeah.
understand and we all understand what it is that we're talking about here from an equipment investment and space standpoint.
Yeah, so the way that we kind of build a system is it's custom built off your gallons per minute, right? So
Okay.
your peak
Yep.
gallons per minute. And so what we do is we find out what the peak gallons per minute is at the property, and then we find out what their operating pressure is, whether that's 90, 120, 160,
Makes sense.
that it varies across the
Yep.
board. And then what we do is we engineer the system behind the scenes. We choose the proper Mazai, and then that we need to be able to handle those flows, right? And so we design a manifold, okay, basically. And so that manifold could be, depending on the pressure variations that we're going to run into or the gallons per minute changes, we'll build a manifold that fits in, that's custom designed to fit the parameters that we're going to see at the golf course,
So
right?
this is specific to a golf course's irrigation system. It's not necessarily specific to a company's like Rainbird or Toro. Every
No,
every every golf course would have a different setup that you would have to build something individually for.
we tap into their existing, whatever
Yeah.
their VFD, whatever they're using, it doesn't matter. What we're able to do is we mimic it with our own VFD and our own PLC. So we
So, but
have
it
our
is
own
it is
system.
specifically built for the golf course as opposed to the
Yep.
company that brought the irrigation system in. You're not going.
100%.
Okay.
We build it to fit whatever system we're going into. So that's why we can handle flows up to 6,000 gallons per minute.
Wow.
Okay. We just spec, and we have more light boxes, if that makes sense. So it's just a bigger, and we would use different lamps.
Right.
Okay. In
Yeah.
that situation, to handle those flows. But that's what's unique about the system is that we're custom building it to make sure. And if we, like in certain situations, so we know about our system, Joel, is this: if we're in a high pH situation, we're going to use we're going to use less of the peroxide reaction. Okay.
Yeah.
We're going to use more ozone reaction.
Right.
So what we'll do is we'll up the lamps in a high pH situation to create the free hydroxyl radicals that way, right? Because the
Talk about,
peroxide
you keep
reaction is going
mentioning
to
the
do that.
lamps. Talk about that before we go
Yeah.
down the road too
Yeah.
far.
So
This is the UV lamps, I assume.
we have special lamps that we custom build, and what they do is they're chambered. So it's UV lamps, just normal UV kind of lamps that we put in. They're made out of a special quartz, and it makes this sky blue kind of look. And so this is how we mimic. And what we do is we pull the air. They're chambered, and we pull the air over down through the venturies, boosting the water through, and then we pull the air actually down through. So we're not actually, the lamp never treats the water, if that makes sense. We're
So you're
treating
not
the
you're not running the
oxygen.
water through a
We're
light
pulling
system.
UV. Yeah, we're pulling UV through the ozone that we're pulling in, and through that area. We can actually direct UV in and draw it through that way as well,
Oh,
through
that's
a tube.
interesting. Okay, that makes
Yep.
sense. Yeah.
Okay. And so that's the, kind of the simplicity of the system is really, it's just, you're not treating the water or the system. And so that's why we play well with beneficial like Greg Elliott.
Yeah, I
The
was going to say,
biggest
because
concern.
UV lighting typically in water treatment is to kill off bacteria, which was
Yep.
going to be one of my first questions because it scared
Yeah,
the
yeah, yeah.
daylights out
No,
of me.
no, that
As
is
a
a good
soil
question.
biologist, I'm like, okay, there's a couple questions I got for you, Kevin. That's going to be the first one. So
Yeah.
you're bringing UV in through an oxidizing process. So what's the value of the UV then if it's not killing off pathogenic bacteria?
You're getting some benefits from it, right?
Yeah.
But because what we're doing is, we also keep in mind this is designed to remove biofilms and other things that cause. Okay, so oftentimes what we end up seeing, and this is in the agriculture world, you see phytophthora and all these other diseases in the almond industry that are just nasty industry wide. But the reason being is because it usually comes from their drip systems not being clean. They
Yeah.
have biofilms and other things, and that's where and cyanobacteria and all these other things that can create layering throughout the
Yeah.
profile. So what we're finding is, what we do is, we're not killing it, because if we go too far, we use a specific nanometer wavelengths in our lamps. Our lamps are focused into 185 nanometers, which is ozone production. It's
Right.
not atmospheric ozone. It's not 255. Like, if you wanted to, for example, our CTO has a patent on UV hospital air treatment. Okay. So it's one of those things where you could go that far, but that's a different lamp. That's a different focus. That's a different everything, where our lamps are focused in to produce this specific atmospheric ozone. Right.
Oh, interesting. Yeah.
So, and we work with a company out of Connecticut, great company. They've been awesome to work with. So we were able to bring everything to the States, and now the lamps are manufactured stateside. They're custom built. They've been tested, overhauled, the whole nine yards.
So
And so,
how many lamps are on a system? If I'm the superintendent at a golf course, how many lamps am I looking at?
yeah, so a 1,200 gallon per minute system like
Based on that
Joe's.
again, yeah.
So, like, we'll go at, like, let's just do Joe's system, right?
Yeah, and we're
Okay,
talking about
so
Joe Budnick at the Peninsula Club in San Francisco. So he's one of your first he's one of your first explorers on this.
Joe's always been my guinea pig, but yeah,
That's a good
in a
thing.
good way. It's
Yes,
always
it
worked
is.
out, so it's not a bad thing.
He's a good man.
But needless to say, yeah. So what we did there is, Joe has really high salts, really high biocarbs. His wells are just nasty, salt intrusion from the bay.
Yeah,
Okay.
tough
He
place.
is fortunate that he has the ability to blend water, but that is getting more and more expensive.
Yep,
And he tries to do that more in the summer months when he's in peak stress.
sure.
So he does the blending to kind of,
Keep the salts
so
away, keep the
yeah.
plant healthier.
And so for us, our whole goal was to, if we can relieve compaction, that's something that from day one, that's something that I've seen in the agriculture side of things. I went out to Fresno State, where we had a system running for 6 months, and I went to a field right next to our field, and literally there was standing water in this one field that was next door to the control, and then we're looking at ours, and there's no standing water, no nothing, and I can push a penetrometer with my fingers 3 feet down to the handle.
So you flocculated, did you?
Oh yeah. And so we saw calcium magnesium ratios come into balance, right? When we start, because what we end up seeing is when we open up the soil, we start flocculating out all the calcium. We start bringing things, and so
Or the
what we've ended,
magnesium, yeah.
yeah. And so then what ends up happening is I've walked so many ag fields in the last few months, Joel, and where you walk them and you're sitting there and you're 6 inches taller by the end, by the
Right.
end of the field. I'm 6 inches taller. And so that putty, this nasty California, just mucky clay, which I'm sure
Yeah.
you
Oh,
have many a
many times.
customer with. Yeah.
Yep.
So, and we're able to just open that up. Fresno State, when we started on their research orchards and their stone fruit and then their corn, we had that situation. You walk through the field and you would literally be 6 inches taller.
Right.
Now that you get 6 months of just running the system, now you're able to get water's going directly down. They're rooting differently. They're
Yeah.
doing all these, and so that's when I was like, hold on, if I can take this to a sports field, we're put this on Greg Elliott's place, right? Same as Joe's. We could remove the need for maybe solid timing, okay, in season.
No.
Okay. Still going to need to probably do some aerification. That's management, and you're going to be
And
managing
you
a
got
really
physical
high surface.
structure, sure. You got
Yeah.
physical
But if we
pressures.
get biology going, if we get the soil health working for you again, then you can start the need for top dressing all the time goes down. You can start doing some other things where now we get to a point, and I know that's against what everyone says is the norm, but the reality is when
Not
I've
everyone.
seen it. No, I've seen it at the Giants. I've seen it at, even at Joe's place. Like right now, we just had a conversation the other day, and he goes, "I got to slow the greens down. They're going
He
bonkers
told
right
me
now."
that. Yeah, he told me that.
Or I mean, speed them up. And he goes,
Yeah.
because they're just growing out of
They're
control.
growing. Yeah. Yeah.
And I was like, well, as we
He wants to slow
remove
the
the
growth
salts,
down. Yeah.
yeah. And as we remove and I just told him, I said, well, just back off on the nitrogen. And Greg Elliott saw the same thing. It's
Yeah.
like the first 2 days we put it out, boom.
Yeah, one of the
Green.
things that Joe said to me is when they first started playing with it, he saw a huge response. But again, anytime you get oxygen into the soil, it would work. Let me ask you a
Yeah.
hypothetical, and you might not know the answer to this, but
Yep.
if I had this system running for a year and then I turned it off, how quickly would I revert?
It depends how much we've opened it up.
Yeah, I would think so. But
Okay.
it
So
would revert. I mean,
you're going to revert 100%. I've said
yeah,
this from day one. Your water quality, like what we've seen in the ag side of things, is just the amount of salt that is coming out of the wells and things
yeah,
that people are using right now, and the cumulatory effect. Like you've done stuff like this.
yep.
People don't calculate how much they're actually putting out. If you have 600 to 1,200 parts per million in your water, and then you're putting that out every
A
night,
million gallons a night, it's an
yeah,
easy math, really.
it's insane how
Amount of
much we're
soil, yeah.
poisoning. Yeah, and so then you're wondering why you don't have to, why your fertilizer budget continues to go up. You're
And your
wondering
disease
what.
pressure continues to go up, and and your mechanical pressure continues to go. I mean, all those kind of things. Yeah,
Yep.
there's no question. I mean, I think you've seen me say this, but I say this at every single academy that I ever teach. And it's one of my kind of joke quiz questions is what's the most important nutrient in turf? And the answers I get is typically calcium, nitrogen, phosphorus, whatever. And it's like, no, it's oxygen, and I can't sell it to you. But it sounds like, Kevin, you are selling them oxygen. And my whole
Pretty
shtick is
much,
now
yeah.
gone if this is the case. I mean, think about it. I mean, you can't, I mean, I used to do the joke, hey, I got 275-gallon totes of oxygen. Anybody interested in buying one? And like, yeah, funny. But,
Well, I think you do. I think guys have been. You've watched it over the years. We had guys play with hydrogen peroxide, right?
yeah,
The journeyman's way of doing it. Ours is just an engineered way of doing it. That's
yeah,
it. And it's actually very simple. This is what I try to tell people all the time, because people try to. If I could, not everyone's going to understand the chemistry and they understand like that side of it and what a hydroxyl radical is. That's
Right.
something that
OH. Yeah.
everyone should understand what that is,
Yeah.
especially in our industry, because that's actually the what oxidize allows us to flocculate, allows us to do what we're able to do with the calcium, right? And so, like, I run into situations all the time. We're working, we were just I work with the Sacramento A's and River Cats. And so we were up there and they have an engineered root zone called Fusion, which is really cool. It's metered in clay so it's like 7% silt or 7% clay, 3% silt, and it's mixed with USGA and they have pug blenders but needless to say, you have calcined clay. So pH
Right.
was a concern going in. And I said, well, we just have to make sure that we got to flocculate it out. We got to make sure that we can get this stuff out,
Yeah.
and it's there. It's just we have to use, and so that's been our big thing is like, we've tried a bunch of different, products and different things, and that's why they eventually came back to me and they were like, well, Kevin, I know you're not going to tell us to do this, but I think we need to put your system in. And
Right.
I was like, well,
Darn.
maybe, yeah, yeah, like at that point, yes, we could help with that, 100%. But what we've seen at the Giants, and this is what's wild. So Greg, this is funny. I don't know if you heard of a company called Raw Stadia, but they are out of Portugal, but they do player safeties for like soccer pitches,
Oh yeah.
baseball, and other things. And so they have much like University of Tennessee has. They have like the automated athlete type
Right. Right.
person
Right. Yeah, I've
and
seen
so they're
those.
testing. Yeah, they're testing basically to field safety, right? So they want to see spring rate return. They want to see all these other things. So we've been able to monitor all the player safety side of things as well at the Giants as we put the system in. And what we've seen is the player safety numbers have got much more consistent across the board. But one thing,
Because the soil's more friable.
decompaction,
Yeah.
decompaction. And
Better
so,
rooting.
yep. And so now we have more stability, but we're not having to create that stability. We're not having this really firm surface that causes injuries.
Right.
Okay. So it's this balancing act as
Yeah.
well.
Makes sense.
European soccer is way ahead of us in terms of what they're
Oh
doing
yeah.
versus what we're doing on our sports fields, but it's starting to transcend over. And for us, if we look at it as this, is like Greg said, he goes, if we can make the field safer, but also understand what we found was this. Greg and I, we were like, why can't we get the spring rate return back in his system? Why won't the energy return that they want to go back to the athlete? There's supposed to be kind of a spring rate, right? And so we couldn't get that number to match, and it was like we couldn't get it to get in the range. It was just outside or just, and so I told him, I said, well, you know what? The only thing that we haven't changed since we put the Rainmaker in, I go, you're still solid time on a regular basis, correct?
Yeah.
And he goes, yeah, every time the team's out of town. I said, we need to stop
So you took the salt
because
tine out because it affecting the surface.
because we're not getting, now we don't need the oxygen down
Yeah.
there.
Yeah.
It's not, that's not the issue. The Rainmaker's doing that for us. It's not to say that you're not going to need to do it from time to time, right? Just to remove thatch or remove whatever it may be. But what Greg's, found is we actually, by removing that solid time, we actually got the spring rate return to come back. Right.
That's
So
interesting.
now it's this whole idea, at some point, surface disruption, and we continue to do it. If we have balanced soil, we don't need to do as much, is what it's kind of showing
Well,
me.
that makes
And I
sense
would
across
love,
the board. Yeah.
yeah. And so that's where I kind of just, if I'm looking at like that, at golf is in a point where, you know, budgets continue to go up, labor's hard to find. We got to, figure out ways to still achieve championship conditioning, which is always my goal at Meadow Club too,
Yeah. Of
was
course.
figure out how to do this, how to keep the greens at a 12 every day, but also allow the
Recover.
soil and everything,
Yeah.
yeah, and everything to work for us. It's a balancing act, but I can tell you right now, if we don't start looking at the effect our largest input, and I've seen this, and you've probably talked about this as well, different soils have different tolerances to bicarbonates, to other things. And when you kind of look at the one thing that the Rainmaker kind of does is, like rainwater, it balances things out over time.
Well,
is
it
we
has
take,
it has an affinity to balance things out, so it'll actually steal things from the soil or drop things in. Let me
yeah,
ask you that you brought up a whole bunch of things, but talk to
yeah,
me about bicarbonates. What are you seeing when with this machine, with this system on a bicarbonate seal?
yeah. So that's going away. It's gone.
So it's
And,
breaking up
and
the
it's right
bicarbonate
away.
chemistry on
Yep.
that surface and pushing it through.
The OH molecules, the
Right.
free hydroxyl radicals are allowing us, because what really happens is when we inject the hydrogen peroxide, we're getting that a tumbling effect. Like if you get a hydrolysis reaction going on is what ends up happening. And we get, so think of like this is how we can take 10% and treat 100% of the flow.
Right. Makes sense. Yeah.
So we're creating this hydrolysis reaction in the pipe. And so that's how we clean. At the same time, it's a gentle tumbling. That's a removing
That's
biofilms, not
creating the
allowing them to stay.
oxidation too, right? Yeah.
Correct. So
So
now
let me
so the salts break down too,
make sense.
bicarbonates break down. Now we're gonna, instead of its particle size being like this, we're gonna get it like that. And
Yeah,
now it can
you're
move
gonna
through.
nano size the bubbles. Let me ask you.
Yeah.
So the big question I have really is, and this scares the bejesus out of me. Hydrogen peroxide, most people are going to think of as a killer of microbiology, and it is. I mean, I used it since I was a baby on any cut that I ever have, and it's the best thing I use when I cut myself. And I remember, and even today, there are products that are rich in hydrogen peroxide that are designed to basically burn off algae, burn off, disease issues. And you would think, I mean, I think in talking to superintendents about this, the one question that's going to come up a lot is that question is, doesn't this hydrogen peroxide kill biology as opposed to being, and some chemistry of hydrogen peroxide is pretty simple. It's H2O2. So what would we do? We just added an extra oxygen molecule to a water molecule, so we made it more oxidized, and that's what you're trying to tap into. But explain that to me and to us. Why
Sure.
is this hydrogen peroxide? And I assume you're using highly concentrated hydrogen peroxide. You're not using the stuff I get at the CVS in a bottle for my cuts. Using
No, yeah.
30%?
It depends. In Canada, we can get 50.
Oh, really? I didn't
So
know
up
that.
there we actually will use 50%, but
Wow.
we don't use medical grade hydrogen peroxide.
Okay.
So there's two different ways. I don't know if you know this, but there's two different ways to make hydrogen peroxide. There's, like a medical grade way, and then
Very
there's a
pure.
more organic way. Okay, that's actually very simplistic. And the reason why we use that is because we don't want to kill, right? So like the hydrogen peroxide, it is a powerful oxidizer. Don't get me wrong.
Yep.
But what we do is at 2 parts per million, when we inject that hydrogen peroxide at 2 parts per million to that water that's been turbulated, pushed through the venturi, broken up, and added that dissolved
So the
oxygen.
hydrogen peroxide comes in at the end of the process. Gotcha.
Correct. When we've infused it with a bunch of extra oxygen, dissolved oxygen, etc., which is how, when we infuse that, we actually create that hydrolysis reaction, which then allows us to break our peroxide reaction, which allows us to break those two
Right.
mixed together.
Yeah.
The H2O2 hydrogen peroxide basically turns into a water molecule and releases the OH molecules.
Exactly. Theoretically. Yeah.
So, and it's almost instantaneous. So we've had chemical engineers look at this. What's interesting is because they're chemically very, very compatible. When we kind of crash them together at that point, it's almost instantaneous. The peroxide goes away and almost turns into water instantaneously.
Right. Right. Oh, that's
Now,
interesting.
yeah. And so we're very safe. And that's one thing that was our biggest concern at the Giants, Joel.
Yeah.
For me was I literally sat there and I was like, we got to be careful because I don't want to screw up a good thing that Greg has going. If we're cleaning it, then that's a problem. And this was before I was even with the company when we were just looking at this at the Giants organization to add in, because I was like, if we can find a way to get oxygen in, this is a win, Greg, for the program.
Yeah.
Like, and and so that's been always kind of my goal, was to fit this into programs, but understand it and that's what I've spent the last 5 months doing. Is we're diving into this with my CEO knows it well, the CTO knows it well, but I said, well, we got to understand how we're going to sell this or explain this to the customer. Because I can tell you right now, this wasn't taught in turf school.
No,
Okay.
no, definitely not. And
And
it's still being criticized heavily by the by the dinosaur agronomists. But yeah, it's
yes,
but I mean it's basic. I mean everything needs oxygen, and that's what you're selling oxygen, dude. I mean I've been saying this for years. I wish I could sell
yep.
you oxygen, and damn, you're selling oxygen now. I'm gonna have to change my spiel on this thing. But
It's
that's
just a creative, it's just a creative way, and that's what got me excited about it to begin with.
yeah,
Was I love drones, I love robotic mowers, I love all that kind of stuff, but this has the potential impacts in
this is
what it
big.
can do for superintendents, what it can do for them to be able to switch
Yeah,
programs is going to be massive. And the synergy between a program and a fertilizer, like your guys' is, it just allows us to
sure. You can
make
make us look
those
better.
programs
Yeah.
better.
Let's
And
talk a little bit about
that's
that because
exciting.
this
Yeah.
does scare me a little bit. Anytime you see something that has this kind of grandiose conversation around it, it almost sounds like a silver bullet. And
Hmm.
I've said forever that oxidation is one of the most important things. But what it does for us in biological soil management is it enhances that process. So this in the void of soil of aggressive soil biology is going to be probably a lot more problematic. But if we can get soil biology really working in combination with this, get foodstuffs down there that create sustainability, and then you come in and you create a better oxidized state. I mean, I can feed the soil microbiology. You can provide the environment and the oxygen for them, but without the two of us, it's a missing piece. But
Correct.
I can absolutely see having our programs that are rich in carbon and mineral amendments, and then have you come in behind it and just keep that oxygen environment. Because if I don't keep an environment, you've heard me say this a million times. The reason why we do 15,000 soil tests a year is because we're trying to make some chemical adjustments so that we can open up the soil to move air and water through so it becomes a physical environment. Not that I would want to eliminate soil testing because I wouldn't want to change that either, but
No.
this just becomes another major tool to jumpstart this process. And I can see where all of this together really becomes a thing. And I can also see where if you're trying to go down just this road of oxidizing soils, it will be less successful than if you go down, understanding core agronomy, chemistry, soil testing, and then of course feed the soil and keep this thing going. I mean, I talked to my team about this, and they're like, "Wow, that's cool, man. We're finally selling oxygen. This is great." But you
Yeah.
got to feed the damn soil as well. But
That's
I
what we
know you
say
well enough to
too.
know that you've seen that.
We know. We tell people right away,
I
you're
know.
going to need to apply sulfur
Yeah,
because
you're going to take it out.
we're going to nuke it right
Yeah,
out of the soil. And
yeah,
there's certain things, and the other thing is that you're going to back off on nitrogen probably initially in this instance, just because we're going to unlock and oxidize out and create kind of turn a bunch of it into nitrate, which is plant available right away,
yeah.
which is what we're
Exactly.
kind of seeing. But then you're eventually the idea that you're growing a crop, you're growing
Of
something,
course.
you're pulling from it all the time. And so you're going to be able to, you're still going to need amendments, and it's the right amendments, right? Like
Right.
you're talking about. And
Yeah.
that's where I always say this is more, if I can solve water quality issues, superintendents' lives are going to get a million times easier, and it's a very
Absolutely.
simple system to put in. And that's where I look, that's where I'm excited, is where I am out in California. As you know, the water situation is just a big problem, whether
It
it's here
sucks. It truly
southwest. Yeah.
sucks.
And I see so many guys that just struggle and beat their head against the wall trying different products, different things. And it's like, for me, it was like, and I was one of those people. I'm throwing calcium and calcium and calcium, and it's like, am I really getting a response? No. Okay, so how do I need to flocculate it? And my background was in viticulture and integrated plant
I
sciences. It's
remember
not
that.
in turf. It's
Yeah.
not in turf. And so for me, I'm sitting there and I'm like, all right, I got to go back to my soils classes that I took for viticulture, and let's figure out, and that's when I went down this road of there's got to be something out there. I looked at nanobubbles. it doesn't do what we're able to do. And that's,
No, it's
I'm
not
trying
sustainable.
to, no. And so I just kind of looked at all these different products, and then I found Rainmaker, and I was kind of like, well, this is interesting. And then sure enough, I meet the CEO, and next thing you know, he's like, well, can you help us get into, this market? And I was like, yeah, let's figure it out. Like, because I think that there's a lot of synergy, but I told him from the very beginning, regenerative agriculture, we can speed it up.
Yeah. And
So
they're changing soils, and that's oxidation is going to be a big part of that. Here's a couple questions that I need to throw at you, but
yeah,
there used to be, and I used to sit on a board of directors of a company that sold the magnets. Do you remember the magnet systems that would
yep,
wrap around the, and there was, it was a very similar concept. It wasn't oxidizing, but it would literally change the chemistry of the water, right? So we would make water wetter, which is what you're doing. One of the problems with that system was that it would be great in the first, 150 yards of irrigation line, and then it would start to dissipate. What happens in your system as I get to the very back end of the golf course with all this material?
the longer that this travels, the better it is. We
Wow.
have, because of the hydrolysis reaction,
So it continues through the
continues
irrigation
to treat
system.
it. So the longer it
Cool.
goes, if we can really treat it at a well source, we do that in agriculture for pivots, for
Yeah,
example.
I would think
I'll
so,
treat
right?
at the well and it will go a quarter mile. By the time it gets to there we've broken the salts down so far. We've done everything. We've oxygenated it so well that we're able to now it's gotten to a point where the viscosity just continues to get better. So the
So at the
longer
farthest
we
point it
need a
might,
hundred, we need 100 feet to be treated fully, if
okay.
that makes sense.
Yep.
Okay, but the longer it travels, the better it gets, which is what's unique about this system. Is now you're eventually going to hit a point. The water can only take so much. Like you have to break down the
Yeah,
salts and
there's
oxidize
energy
them.
and there's chemistry you're dealing with. So
Yep,
I would assume that by the time, traveled a ways, it's going to start to dissipate.
yep,
Explain
yep.
that to me again. How is it? So I'm at the back end of the property. How's it getting better?
Because it just continues to tumble as it's going through. So as we're pushing it down into the profile into the irrigation
Irrigation
system,
system.
it's actually treating itself and continuing
Yeah.
to treat itself. So the further it goes, eventually you're going to hit a point where, like I said, it can only take so much oxygen just
Right.
chemically. That's it's but if we can incorporate it into the structure of the water, that's why we get the viscosity change,
Gotcha. That
which
makes
is
sense.
unique. Which is unique to Rainmaker, is because we're breaking down the minerals and everything. We're not removing them. We're just breaking them down. So now that water continues wetter and wetter. So the first thing that customers see, side hills, right?
Oh,
They
really?
okay,
Yeah.
tee boxes, things like that.
Yeah.
Joe's property is very hilly,
Yep.
right? And so we've been able to monitor his 16 fairway. He always looks like a donut pattern this time of year because he's getting a new irrigation system.
Yeah.
Okay, but we could always balance that out. Luckily, we had the drone, but now we can actually see that the water's not running off to places. It's going right where it needs to go. And that's been huge because the uniformity on that has gotten better and better and better.
Oh, that's
And
pretty
that's what,
cool.
and that, so that's where the water savings piece, the more we open this up, more water they save. They can irrigate more efficiently.
Have you
They can
been
do
able to
deep and
document
frequent.
that yet? Have you been able to actually put numbers
We're
to?
working on that.
All right.
That's gonna take some time. Joe is probably one of the best in terms of knowing
He's very
exactly how much he
attentive to
puts out.
details. Yeah,
Yeah,
exactly.
Greg Elliott though has backed down on water significantly already
Well, in
at the Giants,
California, when
and
you're spending $1 million+ a year on water, that makes sense. I guess
yep.
that's the big question I have for you is that if I'm a golf course superintendent and I want to install this, what am I paying?
Yeah, so with our complete install with VFD PLC, we do all the everything in house. We'll work with your electricians and whoever your pump person is just to put in our ports that we need. But aside from that, we everything's included in the price. And so, as I said before, it's based off of your gallons per minute, and so
Yeah.
it's based off size or lamp size.
Hmm.
But basically what you're going to see is a typical golf course will be anywhere from we've had systems on smaller 9-hole types properties and that are 70,000 all the way up to 150. Just depends on the situation.
Right. And you're going to be able to provide at some point an ROI on the water savings on that. So it sounds like you could
For,
probably
for
pay for itself in, what are you thinking? 5 years, 10 years?
uh, Joe and the two systems that went in this season, that Joe and that
Craig.
uh, Giants
Craig.
with
Yeah.
Greg, they're paying for their systems in year one.
Really?
Yeah.
That's impressive.
So
How much space do I need to account for in my pump house? I mean, what
we
do I?
fit it in. We fit it into the situation. If we have to, we'll actually, make sure we'll punch through a wall or do whatever to get the venturi or the manifold in. So it's just more. We have a custom online design form that we have where
Okay.
guys can literally go in. They can fill out their gallons per minute, take photos of their pump station, and we'll actually send them a design with pricing and everything for it.
Oh, that's pretty
Um,
cool.
so we had some great interns this summer that were incredible from UC Merced that did built us an incredible online design form and some other things that's been really beneficial on the research side of things as well.
So
So
where are you guys? It sounds, I mean, I know you've been working with Joe and Greg a lot. So where are you?
I'm in California right now currently. I'm here for another about month and a half, and then I'm
Yeah, you
moving to
told me you're moving.
Montana.
Yeah, there you go. But
Moving to
where is the
Montana.
business in terms of the turf and ornamental industry? I mean,
Yeah, so we're based. We have hubs kind of like spread out. We have systems all throughout the U.S. So um, we have kind of our hub right now. We do a lot of work out of California, as you
yeah,
can imagine. So
yep.
I'm pretty busy out of here right now. But we do a lot of stuff out of Texas as well.
So
Similar
some
issues.
really crappy water environments.
Yes,
Great.
that's with the worst
Find the
as
worst
as
water you can find.
that's as up as it is, that's been our motto. Our CEO and I would tell. Well, I've walked in and told farmers, I said, "Give me your worst field."
Yeah. Let
I
me
don't.
ask you a silly question. I mean, based on that alone, I mean, East Coast waters are fairly good compared to Texas waters or Nevada waters, California waters. Will an East Coast guy see the kind of ROI that you're talking about with West Coast waters?
Greg Elliott uses drinking water from Hetch Hetchy, probably the cleanest water you'll ever get in the United States.
Wow.
So to answer your question, yeah, 100%. And so that's what was is really unique about this system. And this I just had this conversation with superintendent up at Canyon Meadows the other day, and I just said he was asking. He goes, "Well, is this so? This will work because their water source changes. They go from having really clean runoff water to having a pH of 9.5 like that. And so halfway through the season, his water source will completely switch." And I said
Wow. That
that,
sucks.
and I've seen more mountain courses that have that problem
Why
than
is it switching? It's because
because they go from runoff, they get snow melt, and then
okay, that
all of a
makes sense.
sudden it switch, and then they have to
The
go to
crappy water. Yeah, yeah.
whatever reclaimed water or whatever
Yeah.
they
That makes
have,
sense.
right? And so in those situations, like an acid doesn't solve the problem.
No, not at all.
Okay, and so and so what I was been talking to a bunch of them, and I said, well, that's the beauty of Rainmaker is in either of those situations, it's going to work effectively.
Yeah.
It's going to it will make sure that you're getting the best benefit, and because what happens is when you have that pH or everything else, they're gonna have a little bit more reaction with the ozone, right?
Makes sense.
Um, okay, and so that's where it's balancing act versus if we have a low pH situation, you're gonna have more peroxide reaction.
That makes
Okay,
sense too. Yeah, of course.
okay, so
Chemistry.
yeah, so that's where it's kind of unique. The system's really kind of ingenious in that regard. Is it doesn't matter the environment, you're going to get the added benefit. It's
Customized.
figuring out how to release hydroxyl radicals in both situations, which normally you got a superintendent that's listening to an agronomist, to hopefully somebody like you that understands that. But
Yeah.
most of the time, that's not the case. And
Right,
I hate to
exactly.
break it to people.
Yeah,
So
I mean, and it's funny because water science is, it's still misunderstood and not many people really
well, the
understand.
oil industry, I'll tell you something right now, old Joel. The oil industry has all that information. We just don't study it on our
Right.
side of things.
Yeah. Well,
And they know
yeah,
what
that's all money for
viscosity
them.
does. Yep.
Yeah.
They know what viscosity does. They know how water quality affects penetration.
Yep.
They know all this stuff, and we haven't looked at it. And that's the one thing I said to somebody the other day. I said, you know what's the most underutilized tool right now in our industry is a penetrometer.
Yeah. You don't see many of them on golf courses either. I
No.
have one in my truck often, and I use it quite a bit. But yeah, you don't. I mean, you find probes on the shop, but you don't find penetrometers.
Yep.
Or somebody that would understand it. Let me ask you this, and I don't mean this to sound as negative as it's going to come off, but is there any kind of wear and tear maintenance problematic results to having a system? I mean, are there things that you have to do on a regular basis, or are there things that are problematic or break often? I mean, is it an easy system to run?
Yeah, so initially we have to tune it. So there's a little bit
I
initially
would
going
think.
on where we're going to get the VFD, the PLC to mimic and get everything. So the
Hmm.
air induction rates are dialed in properly, all those kind of things. That's just part of the installation process, right? That's just
Yeah.
part of our process to get it integrated in so it's seamless. Joe now doesn't worry about it. All he does is check hours, same with
Joe
Greg
worries
Elliott.
about everything. What are you talking about?
No, actually, well, after we worked through everything at his property and we got him now he understands it's on a VFD, it's on a smart brain. Do you get what I mean? And so
Yeah. So he
we're
doesn't have
trying
to
to do
maintain that. Good.
everything. Yeah, he was our guinea pig, but the reason being is I just need to prove to my CEO and everyone on our team too, this is the right way to do it because we're gonna have more control.
And you knew
So now
he would be very good at, doing all the detail stuff.
oh, he found
I
every
bet.
bug and thing that you could think of. And that's the beauty of
Yeah.
I always tell people the way that I operate is I used to be a superintendent. So for me, it's show me,
Show
right?
me
And it's the
exactly.
same, it's not okay, like I understand this in theory, but show me that it works, show me that this can operate and that you're gonna be there to make sure that goes well.
Yeah.
And that's the one thing that we take pride in is we're going to make sure that you're going to have an answer if something goes wrong. Somebody's going to be there, or you're going to have an answer right away. But we typically the only things that really go wrong, you could have a ballast go out on a lamp. Okay,
Yeah, of
you have an
course.
extra balance. You have an extra ballast that sits there. Your only cost for the year is the peroxide and the electrical, and
Once
your
you do the
electrical.
install.
Yep.
Yeah.
And then aside from that, we handle all the programming, the VFD, the PLC, the connections, all that kind of stuff. We have people that's what their specialty is.
How much
Um,
peroxide are you going through a year on a golf course?
275 gallons in
So you got
California.
one tote and it trickles out, for the seat. And you're
Two
talking,
parts per a million. 2 parts per 1 million is so little, as you know. It's
yeah,
not.
that's exactly right. And this
Yeah.
again, I don't know if we answered this. Are you talking in the States a 30% hydrogen
Yeah,
fluorescent?
that's what we're doing at
Okay.
Joe's is a 30%, 35%, I think is what Joe
35%,
has.
yeah, something in that
Yeah.
range. Yeah.
And so we just turn up. We obviously because we don't have a 50% concentration, we just
Right.
adjust for that.
Right.
Um,
So that's the only thing you're bringing in yearly, and then the equipment is there, and
yeah,
then
and the lamps are 6,000 hours is what we
okay.
get out of the lamps.
Now, are
And
they
then
constantly on? The lamps always on, or are they
no,
just
so
on
the
when?
system we turn the system on over 200 gallons per minute. And then we go all the way up to 1,200. Right. So so we'll turn it on when they're hand
Gotcha.
watering, if
Yeah.
that makes sense.
Oh, it'll come on.
Um, yep,
Okay.
automatically. So it's based off of we connect to the gallons or the flow meters, and we actually
No,
tell the
that's cool.
system
That's
to
very
turn on
cool.
and off based on.
Yeah, very
So
cool.
that was the one thing that we were trying to figure out is I needed the water to be treated going out to hand water.
That makes sense. Yeah, that's actually
Okay,
brilliant if you think about
so
it.
so I took a little bit of engineering and working with our pump specialists and automation guys, but out of California and up in Canada. But we have two really really, I
Yeah.
mean, guys that automate 1,500 acres,
Yeah.
right? So it's nice to we worked through the last few months has just been working through everything. Now
Hmm.
I've
Getting it to
got
work. Yeah.
yeah, we've got everything done. We've put them in place in numerous places. We're having success with them. We have it's in the ag world, we have over 300 of these things running on almond farms, on,
Big
Texas
properties.
walnuts. Yeah,
Yeah.
big. And that's where, up in Washington,
Yeah.
California, Calgary, it doesn't really matter. It's where, running on all sorts of different crops. And that's why I I got excited about bringing this to this industry. Is there's
Yeah.
things in the ag side that I've always seen that I've been like, well, I wish I could have access to that, or I
You
wish
just
I could
threw out a
access
lot
that.
of pretty high cash crops. I mean, does it work the same on a farmer that's doing grains and
Yep.
less cash crop kind of and commodities?
Yeah. So
I mean, is
obviously,
there's a
dry
return on investment is what I'm asking.
100%.
Okay.
And
That's cool.
the way that we look at it is we've talked to numerous farmers. It's all about, are you being a good steward? Most people are leasing land these days. They
Yeah,
don't own their
exactly.
land themselves. And so, for example, I have a good friend, Jason Miller, who's a great grass seed producer up in Washington, and he literally gets contracts because he's such a good steward.
Yeah.
He does tea brews. He does all these things. He's been doing all this stuff for years and years and years. And the potato guys love him because he cleans up the mess before they come in.
Before
And
they have to have any
yeah,
problems.
yeah. So
Brilliant.
and so if there's a lot of good synergy. I
Yeah.
just wish people would actually understand, like, that's the whole goal with Rainmaker is for us is, getting people to understand that, yeah, we can help prep the soil, or we can help get this, and then you combine it with, a good fertility program, some biology and other things. Now you can actually speed up all these processes, start seeing results. And
That's why
that's the
we're excited.
biggest,
Yeah.
yeah. And that's for me, if we can do that, I look at this as just globally, like we're doing stuff over in UAE, all these other places as well, where they have major issues, but there's huge wants to try to restore farming over there in the
Yeah.
desert
Yeah.
and restore areas. We'll see how that goes, but at
Yeah.
least from a water quality perspective, we know that we can do our part on the
Yeah.
fields, on everything else over there.
Perfect.
So you know, it, we're, I'm excited to, bring this to the industry. It's going to be fun to see people see all the results that we've been able to do. We've been collecting a lot of research.
I bet.
And that's what I've been kind of doing is, and then hopefully we're going to be working with a few more researchers, but we have some great partnerships with University of Arizona,
Good.
in Yuma in the ag side, and then Fresno State
Yeah.
as well, and then University of Calgary. So, and then we're working on doing some stuff with Olds College, which I'll have to tell you about,
Oh, that's cool.
showing different biological products. They're a big biological testing side, and so they're going to actually test them and see
Let me know.
what happens.
I know
Yeah,
where to get some.
yeah, exactly. So,
I hate to tell you
um,
this, my friend, but we've just ran out of time. But
yeah,
like I said, I've been saying forever that oxygen is the most important nutrient in turf. And damn, you've figured out how to sell it. It's been great.
it wasn't me. I just got fortunate. It just kind of
You
fell in
fell
my
into it.
lap.
Well,
Yeah,
you've
yeah,
always been a good opportunist. That's what I've liked about you. But I'm excited because I do think that the combination, this tool, along with biological soil management, is only going to make that process so much stronger. So anything that we can do to speed up the oxidation, obviously, without oxygen, biology isn't going to do the job. But without food, biology is not going to be able to proliferate. So the combination of your work and my work could really be game changing. I think it's really pretty cool. So
yeah.
anybody can find you at Rainmaker.Earth. And you got a nice little video clip up there I looked at earlier this morning, and I'm assuming you'll get more information out on the website. Will
Yep,
you guys be at the GIS up in Orlando this
yep.
year? Good.
Oh yeah, we'll be at GIS, and then we're going to be doing a bunch of regional and local
I
shows
would
as
assume
well.
so, but
So,
certainly if you get out to Orlando this year for the GIS, you guys will have your booth set up. So hopefully
yep.
everybody gets a chance to take a look at it. And and like you said earlier when Greg was asking you, what's new? I hate that question personally, but soil biology is a billion years old, so it's not a whole lot. But this is technology, and the way the industry is going with technology, and what you guys were doing before, with the mowers and the drones and all that stuff. I mean, we've had this conversation on the podcast a couple of times. Guys are going to start to need to hire technology managers to manage all this crap that's going to be running the golf courses. But I think that's a good thing. And I always love having you on here because you talk about some cool stuff. And so let's
Yeah.
get together maybe in another 6 months or so after you've got a couple more experiences under your belt and just stay in touch with where this system is because
Yeah.
again, it's the most important nutrient in turf. So there you have it. Kevin, thank you
Yep.
so much. I appreciate it. I wish you the best of luck. It's Rainmaker.Earth is the website. You can find
Yep.
it fairly easily. And like I said, there's a whole bunch of good information on the website. And my friend, I wish you the best of luck. It sounds very exciting. Like I said, when Joe told me about this last weekend, it was a really cool conversation, and he's very excited. So that says a lot to me.
Yep.
So let's talk again in a half a year or so, and get you back and see where it's all shaken out after the national. But let's catch up, if not before then, in Orlando.
Awesome. Well, it was great to be on again. I always enjoy the conversation, and yeah, let's definitely reconnect in a few months. I guarantee you, we'll have some
I
more
I
exciting
know you well
information to
enough to
share.
know that you
So,
will. Yeah,
yeah,
you will. Appreciate it, my friend. Take care. And
have a
folks,
good
that's
one.
the Earthworks podcast. Please subscribe because we'll tell you when cool and stuff is coming on, like the Rainmaker at Earth. So there you have it, Kevin. Thank you so much.